UC MERCI or UC MERCI. What is it? Well, currently it's a 24-month planning grant sponsored by the UC Multi-Campus Research Programs and Initiatives Office under the President of the University of California, who last summer issued a call for multi-campus programs, something that in areas of research that UC could become leader in if some concerted effort were made and new research directions made possible by advancing technology, et cetera. So inspired by that, I got together people I knew in the UC system who are interested in doing research, and in fact are doing research in music and science. And we put together a proposal, and we proposed 4 activities during this 2-year planning grant period. 6 of these colloquia, which will be occurring at different campuses, although we may have another one here. There will be 2 workshops to discuss collaborations, proposals. The first one will take place this summer at UCLA. And those who are interested in being involved, please contact us about that. There's a web portal that our current website is just a placeholder for a more elaborate portal to music research in University of California and beyond. And finally, and perhaps centrally, there's an opportunity for multi-campus research. So for advanced research students, we think of it as graduate students, but could be also advanced undergraduates even. There's chances to go work with Peter Janata on fMRI and music at UC Davis, work with TMS and motion capture and biomechanics with Ramesh, to work on patient neurology, patient populations with 2 other researchers, Mark Tremo. And the idea is either to have small groups of students or have individual students do multi-campus research projects, something that's very rare at UC. So in addition to getting funded, we got a certificate, which was handed to me by her deputy, the deputy of the president, at her private penthouse in Oakland. And we were chosen along with global warming and overcrowding in prisons as important topics that are deserving of recognition. So the onus is now on us. As I say, the UC MERCI is a license to dream and to propose. And next summer, we will undoubtedly propose the next round of the MPRI program. And we can scale up our requests in terms of dollars, but only if we come together and demonstrate through our activities that we deserve funding, and come up with exciting and interesting plans for coordinated and collaborative program of research in music, mind, brain, body. So currently we have 7 members of the board of MERCI and one associate. We hope to have more associates. So I took a degree called music psychobiology here at UCSD 30 years ago, just 30 years ago now. And I've been working as the director of the Swartz Center for Computational Neuroscience. We're usually working on human EEG and its applications to various questions in cognitive neuroscience. John Everson is also at the Swartz Center and has been working on rhythm and brain, perception of rhythm, production of rhythm, using brain imaging with MEG and EEG for over a decade. Ramesh Balasubramanian had a wonderful summer school, NSF-funded summer school on music last summer. That was sort of the genesis of this idea of UC MERCI. He was trained in physics and as a psychologist and studies synchrony and motor behavior and is using TMS now and EEG. Sarah Creel here, who we just met, is Associate Professor of Cognitive Science and studies development of language and musical perception. Julene Johnson at University of California, San Francisco in the nursing research department has a wonderful prize of a flutist and has a wonderful project to take to bring choir directors into senior citizen homes in San Francisco of different ethnicities and to track the health of these participants who participate in a cappella singing for a year. Wonderful idea. Peter Janata is a very inventive research psychologist at UC Davis who uses fMRI and other methods to study things including memory, autobiographical memory for music, the groove experience, this harmonic structure and its mapping in the brain, and so on. Mark Tremo at UCLA is a neurologist who for many years has taught and had found even a private institute for studies of music and brain. And finally, Gert Landkriet is our first associate and helped us in the proposal. He is professor of electrical and computer engineering, and he studies music selection, better algorithms for Pandora and the like, which is actually a significant business now in California, and growing business in California. So the website is there, and we will be adding quite a bit as time goes on. Now, what is the aim? We said it was to develop a multi-campus University of California initiative for collaborative research on human musical experience and communication, using new tools for brain-body imaging and data mining. So new science brought to important old questions. And I chose the words experience and communication because I think these are two things that traditional musicology, traditional experimental psychology has not focused on, but I think are, of course, the heart of the power and the intrigue and the meaning of music. So musical experience and communication. Helmholtz, who wrote his famous book on the sensations of tone in the middle of the 19th century, already pointed out that this work is really an interdiscipline. It's not a discipline, and that he had to put in the beginning of his book that depending what background you come from, you're going to read these what I say very differently. And he was talking about physicists, physiologists, musicians, professors of aesthetics, and so on. And that remains true today. There is no natural home for music psychology in the university. Certainly there's no department like that. And it's not then a major part of any department, including the music department, who has rather different aims. So that means it's a creative endeavor. Now, what is musical experience? I was inspired as a graduate student when I read this 1922 monograph in which the scientist in Cambridge used what he called a laboratory quality Victrola to play light classical music, overtures and so on, to people and just ask them what they experienced. This was the era before behaviorism, when you could ask your subjects what they experienced. And then he categorized what they experienced. Well, when behaviorism came in, it became verboten. I remember some psychophysiologists stiffening when I asked, well, what did the subjects actually say they experienced with your complicated stimuli? And he stiffened. He said, I am a psychophysiologist. I ask my subjects nothing, only the button press. So, but this was before that era, so he had no such scruples. So he said very few people, when he asked them what they experienced, they talked about the modulation to B flat and the entrance of the trombones, and they only talked about that, and no one else mentioned anything like that at all. These are, of course, the musicians. The associations, so many of his subjects said, well, I had visual associations. They said fairies dancing and so on, and that may have been more germane to the music of the time that he was playing them. Other people talked about chills and thrills, physical sensations that the music caused them. And then, as he says in Cambridgian English, the relation of the character to the intersubjective aspect. Those are people who are the most, actually the most connoisseur of music, who talked about the expression of character. I heard pathos, I heard striving, I heard yearning, I heard these deep-rooted human emotional qualities that are not passing emotions, but that pertain to the character, the human character itself. And that's what they experienced and was communicated to them. And then, of course, he did mention the importance of the mystic feeling. So music has been used for mystic purposes, that is to say, to engender unordinary experiences through the ages. Now, of course, not only humans like music. I think I won't take time to show this great YouTube video of the dog who's grooving to the music, and every time it stops is really heartbroken. But if you see it on YouTube, you'll like it. But of course, humans love music. I've read that perhaps only 1% of people don't really respond to music at all, and most people do, as we see from an early age. So Carl Seashore, the preeminent American psychologist of music in the middle of this last century, wrote a valedictory book, Why We Love Music, in which he wrote essays considering this and relevant questions. And he pointed out the love of music is essentially an unanalyzed feeling. Countless people feel the aesthetic appeal in music without understanding anything about it. It may be like the notorious puppy love, which is frequently blind, but nevertheless deep. He concludes his chapter by saying, then why do we love music? Among other things, we love it because it creates a physiological well-being in our organism. And undeniably true, the use of music for therapies in many dimensions of clinical care is ongoing. And research is, certainly more research is needed there. Music is built from materials that are beautiful objects in themselves. How do we respond? What sounds do we respond to as beautiful? It carries us through the realms of creative imagination, thought, actions, and feelings in limitless art forms. This was an essay, of course, from the 1940s in which such language was prized, but it remains undeniably true today. Music is self-propelling through natural impulses such as rhythm. Music is the language of emotion. It is a generator of social fellowship. One of the main benefits of the a cappella choir project in San Francisco is undoubtedly the social communion. Music takes us out of the humdrum of life and makes us live in play with the ideal. It satisfies our cravings for intellectual conquest, for isolation in the artistic attitude of emotion, and for self-expression, for the joy of expression. He's speaking here of the highest musical attributes and the striving of musical arts. So, of course, music experience, and in fact, all human cognition is increasingly understood to be embodied experience. We construct an interpretation of what we experience through our multiple senses based on our experience, and our experience is of being an embodied agent, of being an embodied agent in this world. So music naturally not only appeals to our sense of movement, but also even, I believe, even our understanding of music, melody, harmony, and rhythm, is essentially related to our experience of being moving in the body through the world in a way that I think has not been properly studied yet. And this, of course, is true for young and old. Now, what music communicates and what kind of embodiment it produces depends. It goes from the the lowest sort of lascivious purpose to the spiritual. Notice all these singers have their eyes up. Music as communication is another topic that is much under. It's an approach that is, I think, much underexplored and underappreciated. Here's Seashore again. The successful performance comes in inspirational attitude, the semi-ecstatic, ecstatic feeling of the beauty one seeks to convey, a state of forgetfulness of self and concrete facts. And I think performers can relate to that. Thus, music is a language of emotion. Through it, the composer and the performer convey their own emotions to the listener. It is a message and a means of communication that enables the performer and listener to live for moments in the same tonal world of pleasure. So again, there's an essential social aspect to music as communication, to experience together what he calls here the tonal world of pleasure. Now, music as communication, of course, is most blatantly used in love songs. Love songs form most of the music industry in the world. In terms of dollars and cents, popular music is mostly love songs. Successful and unrequited and unsuccessful. I found there was someone who had written a science love song also. So, although rarely these days in our culture do we actually express to each other through music, I was wondering if she was thinking, this is going to be a big adventure, this marriage. But music also has communicative purpose, very important communicative purpose at the societal level or the cultural level. Show me, I thought to myself, show me a military that does not have a marching band, and I will show you a military outfit run by psychopaths. And I think probably, I hypothesize that that's probably true. But every kind of musical group actually is not only embodying and carrying on a musical tradition or creating a musical tradition, but it's carrying through that, it's communicating the essential attitudes, the rhythms, the emotions that created that music, that caused that music came out of. So it preserves important, intangible cultural attitudes, experiences, and values, sort of without saying anything about them. And that's true for all levels of culture and all types of culture. So music has a very important, I believe, role to preserve cultural values, spiritual values of everyday life as interpreted by a culture. Now, why is it that we can respond to music? This is my idea that I'm expressing now. It's very hard to tell what other people are feeling. Perhaps for an autistic, this might be more literally true than for you or me. But to discern and experience empathically the feelings of another person, not the theory of mind of what they're thinking, but the theory of heart, what they're feeling, and thereby to know their motivation to act, to react, to interact, is crucially important for social relationships. Without that, there's no trust. If I have no idea what you're feeling, there's no trust. And social relationships become really impossible. Now, of course, animals also are very interested in what you're feeling, as anyone with a dog will know. But in human culture, there's all sorts of reasons to not reveal what you're feeling. There's positive benefits for not revealing all of what we're feeling. So that means that knowing what a person is feeling simply by the cues, visual, motion, auditory, tone of voice, gesture, subtle cues, is something that we're all really very expert at, but in an intuitive way that we don't consciously really think about. Here's a beautiful picture I found on the web. It's from a real psychotherapy session. Now, we can all, I think, see very deep feelings involved between these two people who do actually know each other. One can sense something very important and deep and emotional is happening to them in their communication at that moment. But what cues do we use to know that? Well, we could make up a story, but essentially we don't think about those cues. We just think about what they feel and how we feel it. So this affective perception of humans is something that's built into us. It's extremely important for our social life, our life as a social creature, and it's so important that system for affective perception can relate to any slight cue, a turn of the head, a small gesture, and it can even apply to seeing this as a pilot flying around, seeing this as a little conversation between two people who feel things. So what are the questions? So because of that, I think we have, as humans, the remarkable ability to feel, to learn languages of emotional communication, and derive emotion, produce and derive and perceive emotional communication from something as abstract as music, even instrumental music without words. And how that happens is, of course, a primary scientific question. How does the composer, the musician, use pitch, harmony, rhythm, gesture, and melodic gestures, articulation of the notes, timbre of the notes, to communicate? And then what role do cultural associations also play? Other questions that, for the science of music, that I think are most important and certainly represented in the UC MERCI group are, how does music support health? I don't know of anyone, except if you play your rock and roll too loud, who would say that music is not healthful. How does music support learning? Not only how do people learn music, but how does learning music support other types of learning? How does music support culture? Beautiful question that has very little, relatively little science, certainly experimental studies. And then applied topics, commercial topics, such as what is the best music selection method? It has actually economic importance. It also social importance because, of course, most people are consuming music from their iPod, their iPhone. Okay, I want to go back to this ability to understand music in terms of our ability to impute human emotion to the slightest, to any stimulus. So I want you to imagine an animated movie, say Disney style, about Farmer Brown's farmhouse. And there's a character Okay, there's the character. And I want you to imagine, you can close your eyes if you will, or imagine closing your eyes, and hearing just the soundtrack. That would go. Okay, who saw a scene there? Who imagined the scene? The mouse coming out of his house, the mouse coming, creeping around, and seeing the cat and running back. Now, why was that so easy for us? Well, I gave a lot of cues. I gave the dynamic cues, rhythm cues, but I also gave this pitch cue. So essentially what we were doing, we were mapping pitch, this physical pitch frequency, onto, among other things, onto these affective dimensions. Dimensions of moving from safety to threat, from at rest to effortful, making efforts, from home to away from home, and then from perhaps low to high. Perhaps the mouse was going up. So this is very effortless for us. When we made that imagination spontaneously, we were making this mapping between a physical dimension and these affectively latent dimensions. And I believe this is kind of the ground of our ability to interpret music as meaning, as meaning, to experience music as meaningful in some pure sense. That there is a mostly unconscious or not consciously formulated mapping we're making between these physical dimensions and some important, ecologically important dimensions to us. Now, the same story goes on when you look at harmonic pitch hearing, not just pitch on a continuum, but you look at the ratios, the musical ratios contained in the harmonics of a single tone on a string or a wind instrument or a voice. These can be made in, these relationships between the first harmonics can be made into a web, which really contains the structure of our harmonies, of Western harmony, but also very much used in many other musics. So multiplying by the frequencies by 3, dividing by 3, or multiplying by 5, or by 6, you get different musical intervals that can be made into a scale. How can this whole field of intervals be made into a scale? Well, you can, the more sharper than equal turning is down and flatter is up, but in this picture, it turns out. Well, what you can do is you can notice that in this field, there's some notes that are almost a fifth apart in this case. And therefore, you could take the lower notes and fold them over into the upper notes, and then you could have this cylinder here. And then you can notice that in this plot, just because of the arithmetic, that this note is almost a fifth from that note, and therefore you can fold the edge over this way, and that would be folding the cylinder into a donut. So this is the 53-note scale given by the just ratios, the integer ratios. If you do the same procedure, looking for ways that you can fold it without the crease being unnatural intervals, what you get is the 12-note scale, the 7-note scale, the 5-note scale, used in most of the musics of the world. So there's this beautiful algebraic structure underneath our music. Now, so if you identify these and then do that folding again, then you get essentially the 12-note scale, and so on. So there's this surface of a torus. How do composers and musicians use these harmonic relationships to communicate effectively? How do we, as listeners, use them to interpret effectively the use of harmony in Western music in particular, or use of note relationships in other kinds of music? Well, here's Osgood's semantic differential from the 50s. He gave people pairs of words like happy and sad and asked them how far apart on this scale they were. And of course, happy and sad would be quite opposite. But bored and sad wouldn't seem that far away. And then he put everything into a big IBM computer with cards and did multidimensional scaling. And he came down to 3 dimensions, 3 principal dimensions. He called it evaluation, potency, and activity. So good, bad, strong, weak were the 2 first dimensions. So there's this surface in which all sorts of relationships between affectively laden words, adjectives in this case, seem to live. So that means that there's some sort of continuous ground space of affect that has multiple factors, whether these are the exact axes or not. So, words that are similar are together in this space. Now, I found an obscure book by Alain Danilou in which he essentially gave the elements of this theory that actually if you look this direction in the harmonic chart, you get these intervals convey a sense of activity, of strength and activity, and in this direction, passivity. This direction, sensitivity, and this direction, insensitivity. What he was saying, I realized, actually, was that not that we learn these 53 associations, or even 12 associations, independently, but that there is a mapping such that this 7th here is the sum of, the affective quality of the 7th is the sum of activity and sensitivity. That there is an actual vector field. We learn the mapping of an affective space, continuous affective space, onto this manifold. It's a beautiful theory, really. It's something that I would very much like to find someone to work with to test. It means that we're not learning just individual facts, individual notes. We're learning something much deeper with it that is able to create a palette, an emotional palette for us, just as an artist with their color palette will be very attuned to how they're using the different colors to convey emotional qualities. Now, of course, we could do these things with EEG these days. Here's Julie Anton, and I'll briefly say that we did an experiment in which subjects listened to suggestions to imagine different emotions, carefully controlled. We recorded high-density EEG. We did elaborate analysis of the dynamic state the EEG went into. In fact, it was the high-frequency sort of frisson of some of the cortical structures that was most relevant. And in that space, the different emotions all lined up, similar emotions lined up next to each other. The brain went back to that very similar dynamic state when a similar emotion was being experienced. And in fact, good, bad was judged by groups of listeners to be along this line, and the lineup, the EEG gave us a correlation of 96% with that. So now you can read from EEG how positive, how negative you feel about something. Can you read other dimensions in EEG? I think it is certainly possible. We haven't shown it yet, but it certainly is possible. There's a tremendous amount of information in EEG that hasn't been exploited previously because of the analysis methods were insufficient to do it. Compassion was an outlier here because people, when we asked them what they thought of when they were trying to imagine compassion, they said, oh, it was a horrible accident, we were so sad, and we were feeling, We found out what part of the cortex was producing this high-frequency noise, frisson, I might call it. The more positive the emotion, and it was these 2 areas in red. For a long time, I couldn't find in the fMRI literature those areas, but then I found it. This was a music experiment by Tom Fritz, the same areas. So either with EEG or with fMRI, which of course involves lying in a scanner where you're going bang, 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 or in a quiet EEG chamber where you can listen to music or any kind of situation. So it's things, the methods are now available to do a much more in-depth study, either with metabolic imaging or with electrophysiological imaging of how we experience music. And this was a metric modulation study. I won't take time to show it, but John and I have been analyzing it. And here's an ERP when the subject was changing the rhythm from 4/4 to 3/3/2. And you notice how exquisitely the electrical signals from this part of the brain were following the beat. Not only the 4s that they were tapping to, but the 2s where the dotted lines were, the dashed lines, where they weren't tapping. So this ERP didn't have to do with tapping, it had to do with sense of the beat itself. But interestingly, this part of the brain didn't show any relationship to changing the meter, which musically is experienced as a kind of disorienting thing. In fact, it was another, and here in the frequency domain, we looked at bursts of 25 hertz that were coming from this area. Again, not connected with the beat in the music, but not connected with the modulation. We had to look at a different place in the brain, more frontal, medial frontal, that showed clearly that when the evidence that the brain dynamics changed dramatically when there was this need to twist, to do a metric modulation to a completely different meter. So the era of studying EEG, studying music experience physiologically using new imaging tools is certainly here. There's a rich set of techniques that one can use, and it's all available. And for any of students or someone who knows students who would be interested in this sort of thing, there is money in the UC MERCI project to support that kind of work, which may be rare for music students. So I hope it will inspire some from any department to work with me or with John or Sarah here or with members of MERCI across the campus.